Okay, in this lecture topic in operating system, what is called as the process synchronization. So prior to this, students you already know what process is all about. It's a dynamic entity. It is something which is real, real in existence. Now regarding the next thing, which is the synchronization. So why synchronization is required? That is the next question. Once we know about the process. So let me talk about the different types, the issues, and the scenario that can arise basically. So you can see in the slide that we already know that there are two types of process. One is cooperative and one is independent, right? The independent process is something which is actually cannot be affected by other process, or it can't be affected by other process. But the problem arises due to this, the cooperative process. I mean, this is something which can be affected by other process, or it can also itself affect the other process. Now that is something of concern. We need to understand different situations here. You can see here in the example that this is a shared resource. Okay, this is, for example, like the printer device. Okay, so you know that different user, different applications program. Like here you can see like user 1, user 2, and user 3. Different users is trying to access the printer at the same time. Okay, at the same time. Now, due to that thing, the particular process may involve some common data. I mean, accessing the printer may involve some variable, may involve some procedure, which will be accessed by user 1, user 2, as well as user 3. Now, that is problematic. In case all these users were using different variables, then things would have been much more simpler without any complications. But as because the users are using the same application, they definitely are accessing same data. Chances are very high that the data will be common. Okay, they are actually using the shared resources. So as I was saying, that issues can arise due to this reason. Okay, as multiple process of different application program is using or going after the same shared resource access. The operation can be of any type. You can see, like here, this is write, and this is read. This is write, and this is read. So it can definitely happen like that, isn't it? Like one process 1 is trying to update some value over here in this shared memory location, which the process 2 is trying to read, okay? And even process 2 can also write the value here, which the other process is trying to access, is trying to read, okay? So that is problem, the issues that we are having. Take this example for the process communication between themselves, okay, what we call as the IPC, or inter-process communication. So you can see there is the process 1 and there is process 2. Okay? And both of the processes are going after the similar kind of task. They are definitely at some stage they are using the same variable, like here count, and there also count. Like one process is trying to increment the value of count and the other process is trying to decrement the value of count. Now that is definitely problematic. See, if we assume that the value of count is right now at 5, okay? So what is our general assumptions after these effects? Once the value of count gets incremented by one process and decremented by the other process, we know that the final result, I can surely write here, the final result is 5. After adding 1 to 5 and decrementing or subtracting 1 from it. So 5 plus 1 minus 1 will result in 5. So this is our expectation. This is consistency. no matter process 1 executes first or process 2 executes first, this is bound to happen. But this is not going to happen because of the interprocess communication. See, even in a much more detail, even operation was looking very simple like increment or decrement, but actually the instruction, this is something like this. Okay? And what is happening, like process 1 is trying to load the value of count variable into its local register. This is register, this R0. Okay, it's a CPU register, processor register. So it is trying to load the value of the count value over there. So definitely this R0 gets the value 5 there. And then it is going for the increment of R0 becomes 6, which will be finally copied in the count variable. And doing the similar kind of task, but instead of increment, it is going after decrement. So these instructions are all assembly instructions. Once your code gets executed, it is compiled basically, this instruction gets generated. So it is trying to move on to a different register, CPU register. Then the value gets decremented on that register, and finally the register value gets shifted in variable count. So if you look here, once we have considered like this ordering without interleaving, let me highlight, without interleaving, what will happen? That once the line number 1 here, without interleaving means what? Those consecutive instruction cannot be suspended, cannot be stopped. This one starts line number 1 there, moving the data from count to R0 register. It must finish the R0, then it will shift the value from R0 to count. There should not be any interruption between. See the ordering? Process 1 is executing all the 3 lines, then comes process 2. So that is what is happening here. Okay? So process 1 will read the value of count to register R0. We'll go for increment, that means it becomes 6 and 6 gets saved in the count variable. So the count variable change happen like this, 5 to 6. And then it starts, then it will go after decrement operation. It is reading the updated value of count, which is 6 here. And once it is loaded in the CPU register, it gets decremented so that 6 becomes all over again 5 here. And in case the ordering is somewhat bit different, like process 2 starts first, finishes first. It should be just the opposite. First the decrement of 5 to 4 happens, then increment from 4 to 5 happens. Okay. So this is something what we did. But this is something which is not going to happen. I mentioned in the red color, you can see this is what if something happens with interleaving. And means what? Let me show you that. Processes is definitely allowed to be stopped. Finish the execution. So yeah, fine. The process 1 is in the line 1, it got executed line 1, then it is executing line 2. Like this line 1 is done, line 2 also done, and it got stopped. Scheduler is allowing process 2 to start. Like it is also going for line 1. Then the second instruction line 2, and it is being stopped. Then again the context switch can happen from process, can definitely happen. This is the scenario allowing the interleaving, means the context switching even before a processor finishes the task. Updating that shared the thing here. If process 1 executes line 1 and 2, means going after increment. And see closely, the increment only happens in the register, not in the count. In line number 3 is set, but it is yet to execute line 3. So it is holding the incremented value in R0. See, it is reading the count value, which is still 5. So the over 5, the decrement operation happens. So basically in the two register R0 and R1, I'm writing this. In R0, the incremented value of count stays. And in R1 register, the decremented, that's the thing. Now, it's a matter of time, like which process will be finishing first. In case process 1 finish and then process 2 finishes in the very end, So process 2's effect will last. Count's value which is 4. So the count gets the value 4 there. But in another way, if process 1 finishes last, see, if process 1 finishes the count with the R0 content of 6 will be happening in the very end. So first in count 4 gets written and then in the same count variable it. Now is the problem. This is inconsistent. We can't have this different value being saved upon executions of this. Okay, we must have this fixed value like whatever we have seen in the prior slide. We must have a clear-cut idea about what should be the final value. But now we are not getting any clear-cut idea. It may be 6, it may be 4. So there is definitely a problem something, or we can also call them as ambiguity. So that is the problem with the say in this lecture, okay? And at times we will go through the different solution, but before that we should know that some basic things about this, the interprocess, and what is the criteria the solution must have. So definitely, whatever problem that you just got to see earlier, this process 1 and process 2 is actually racing with each other. And the output to which process finishes first. They are interlinked and it totally depends on the order. So if this is the situation, we will call that as a race condition against each other. Another thing is very important, students. Thing about critical section. Critical section is something in whichever process code, a process or some process will access the shared resource. Which access the shared resource, shared variable, common data, we will call it as a critical section. So anything before this count plus line or a critical section. But you can clearly see that there are two processes which is accessing the same variable. They are trying to update the same variable, and that variable may be related to some device. Some if the multiple processes go after a common variable, shared variable, then definitely it's a problem. We call that part as a critical. So remember this fundamental part, and next I'll talk about the synchronization mechanism. So this is this. It's a mechanism. It's a way through which the process will be allowed for a very coordinated executions, avoiding all those inconsistency problems. Okay. So they receive way in a very coordinated or synchronized manner, so that there is no inconsistent effect that is visible. Generally, remember that we must add for the synchronized mechanism solutions. One is the entry section and one is the exit section. This is something which we are about to add manual so that the process is resolved. So the entry section is something which will ensure that at a time only one process is here. If one process is updating the common data, I mean it is very much inside the critical section part of the code, no other process are inside their critical section. So the entry section code, whatever that you will witness, you will see in the lectures, that will ensure about this fact. Critical section program where the shared resources are accessed. Okay? And finally there is exit section, like once the leave the section, so it acts like an exit gate. We will see in the solution that in the exit actually making some changes with some variables value. So definitely it is the exit gate, and the process will definitely make some changes. About these three very essential part: entry section, critical, and exit section. Now, for any and every solution mechanism, the criteria is these three. This is the third criteria. So regarding mutual exclusion, you can see I have told you that at a time only one process is present. Okay, if P1 is very much in the critical section, all other process is blocked. They can't enter their critical section part. Okay, let that process finishes the updation with the shared resources. Let the update be visible. It should persist. It should be permanent, and let them find this process resume. They can complete their critical section, right? Now this is the second. This is the first one. This is the second one. The progress. Like if you relate to the very practical example, like if I am not interested towards something, what will happen practically? I will definitely. It is not like if I am not interested, I will block everyone else. So the same thing is applicable here. Process entry into the critical section does not depend on another process entry into their critical section. Fine. Let other process access their critical section if they are interested. So that is progress. There should be some progress which should be visible. And last but not least, this is dead waiting. So, like for example, the process P3 have requested enter the critical section. Okay, it is done with the entry section part. So now it very much wants to enter the critical section. Now there should be a limit. There should be a bound on the waiting time. It should not be requested to access the critical section, enter in the critical section. It will like wait forever. That is never going to happen. There should bound. The waiting time must be bounded. Otherwise, this unfortunate process will never get the guard. So this is totally unexpected. That is never expected to happen. Okay, there should be by that waiting time, the limit of the waiting time, the process will definitely enter the critical section. Okay, so I'm not starting the solution in this class in a much more meaningful way. So let's just take this example. We all know the situations, the facts in front of it, right? So let me explain that with a real life example. The first criteria, which is mutual exclusion. Person is allowed to enter the facility and allowed to swipe the card and go for the transaction. Like here, this person is very much using swiping the card and going up to the transaction. So at this time, all these person, they are waiting. They are waiting like when job and he will come out from the ATM, right? So one thing for sure, that at a time only one person can swipe and go for the transactions. So that is mutual exclusion. Same thing happens for the processor as well, isn't it? Now what about the next criteria, which is the progress? That was our second criteria, right? See, progress means what? We need to understand like if some process is interested or not interested about getting inside the critical, fine, let the other get inside the critical section. So take this example. Suddenly, these persons can realize that he doesn't have the card. Okay? He doesn't have the debit card. That's a problem. Without that, what will happen? That person doesn't have the authority to access the ATM facility. So definitely I can relate to like a non-interested process, non-interested person. However, no, that will totally turn this situation into complete chaos, and definitely this or must leave the key. Let all this person who must use the ATM facility. So a person which was not having or holding any authority to access this ATM machine, so definitely he or she should leave that too and let the other information. So that is regarding the progress. There should be a progress. It is not like it is totally stuck at some stage. All person, all process in the operating system's point of view, they are waiting to get in. Never happen. Okay? And talking about the last thing, the last criteria, the bounded way, to be bounded. These person very much know exactly for how long the person is waiting. Like this person know, okay, I am waiting for him to come out from ATM. Then I can enter and access the facility. This person, no, okay, fine. I'm basically one person in front and one person in the ATM. Two persons basically. This is waiting, this person is waiting for 3 people, this is waiting for 4 people, and this person, even the last person, definitely how long he or she have to wait. Like he is waiting for 4 people in the queue standing in front of him and one. So definitely there should be a limit on the waiting period or waiting time. This last person, it will never happen that he wait. That will never happen. He definitely know what is the exact waiting period he have to spend, isn't it? So these are the criteria for the process synchronization solution. At times in lectures we will talk about the solution and you will realize that different solutions is actually satisfy criteria for process synchronization. The process must access the critical section in a mutually exclusive way. One days or certain progress on accessing the critical section. It will never happen like a bunch of processes waiting forever to get inside the critical section. And finally, there should be a bound or limit to the waiting time the particular process can or have to spend, right? To get its turn to enter the critical. So that is the thing. Okay. So we will talk about in detail. We will talk about different solutions in the upcoming classes. Okay. So I sincerely hope that all of you have understood the very basic concept about what actually goes wrong in an interprocess communication, why there is an issue, and what about the solution. The solution must be looking for which criteria to satisfy. Okay. So all the students, thank you for listening to this lecture.